Bismillahirrahmanirrahim. Assalamu alaikum, dear students, and welcome to our next lesson. It is actually a review lesson regarding to our all the topics which we have read in our second term. Taking a start from two of our topics from the second term, that is the deformation and momentum. Deformation is actually a topic which is relating to the Hooke's law. Hooke's law, it is actually relating the extension in an elastic object and the force exerted on the object. When we just talk about the deformation, there are actually two types of behaviors of the materials which are there when we apply some force on them. When we apply a force on a material and after removal of the force, it returns to its original size and shape, then we say that the material is demonstrating elastic behavior. But when a material stays deformed, means doesn't move back to its original size and shape after the force has been taken away, then the material is demonstrating the plastic behavior. Even on the elastic materials, if we apply too big force, then the material will lose its elasticity and will be deformed permanently. Robert Hooke was a scientist who discovered that the amount the spring stretches is proportional to the amount of force applied to it. This statement is known as Hooke's law regarding to the deformation of elastic objects. This means if we double the force, extension will be doubled. If we triple the force, extension will be tripled in the elastic object, and so on. Then we have a demonstration. We have some demonstrations regarding to the force and the extensions produced in a spring elastic material. By applying a force of 1 Newton, the extension is 2 centimeters in it. So if we increase the force to 2 Newton, meaning we double the force, then the extension will be doubled, means it will become 4 centimeter. By tripling the force, extension will be tripled, that is 6 centimeter. Along with all these things, the graph is there, which is presenting the relation between the extension and the force. So, and when the force is increased 4 times, the extension is also 4 times. But when we increase a force 1 Newton more, we see that the extension is not the same as in the previous cases. Here, actually, this elastic object has passed out its limit of proportionality. This point up till which the extension and the force are directly proportional means it is showing the same extensions for the same increase in the force. Then this is called that the force and extension are directly proportional to each other, and where the extension is not the same as in the previous cases, then this point where it shows more extension by increasing the same force, then this point is known as the limit of proportionality. So this point is known as the limit of proportionality. The proportionality is 4 newtons. Limit of proportionality of this spring is 4 newtons, as it is showing more extension by increasing 1 more Newton on it, and so on. If we increase 1 more Newton in it, then it will show even more extension in it. So the graph will be curved towards the extension axis. This is the extension axis, and it will bend towards the extension point. Is it clear? So this is the limit of proportionality. Up till to this point, the spring is obeying the Hooke's law. Up till to 4 newtons, it is obeying the Hooke's law. So Hooke's law, if we just write it down in an equation, it can be written as F is equal to K into delta X. Means K is the spring constant, delta presenting the change in extension, X is presenting the extension. All the things has been described here. Extension delta X is sometimes written as delta L. E भी लिखा जाता है, बाज़ का delta L भी लिख दिया जाता है, but mostly it is presented by X. So We find the extension from delta x is equal to stretched length minus original length. अगर हमें कहा जाए कि कितनी इसमें स्ट्रेचनेस पैदा हुई है, तो एक्सटेंडेड लेंथ या स्ट्रेच लेंथ में से ओरिजिनल लेंथ को माइनस कर दें, you will get the extension produced in the spring by the application of a force. So there is a problem, there is a question to understand how we are going to solve the problems by using the Hooke's law. A weight of 8.7 Newton is attached to a spring that has a spring constant of 190 Newton meters. How much the spring will stretch? So spring constant has been given, force has been given, and we have to find out the stretchiness of the spring, that is the value of x we have to find out. So applying the law, Hooke's law, Fs is equal to kx, substituting the values, we can calculate the extension produced in the spring. So students, that was a topic regarding to the T formation. Just try to revise these things and try to practice them with the help of the provided worksheet along with this lecture. So the next thing, that is the momentum. What is momentum? Momentum is actually the amount of movement in an object. Simply, you can say the motion of inertia. It is known as momentum, presented by a variable p. So in the equation form, it can be written as momentum is equal to mass into velocity. So momentum can also be defined as momentum is the product of the mass and velocity of the object. So P is equal to mv. Units, SI units of momentum will be kilograms meter per second. This relation shows that more the mass of an object, more will be its momentum. If two objects are there moving with the same velocity, then an object having more mass will have more momentum. And in the second case, if the two objects having the same mass but moving with the different velocities, then the object moving with higher velocity will have more momentum and the other one will have lesser momentum. One important thing is there that the objects which are not moving means they are at rest. They have no velocity. Velocity will be zero, so the momentum will also be equals to zero, means they will have no momentum. Then the two important points regarding to the momentum, that is impulse and impact. What is the impulse? Impulse is actually the change in momentum of an object due to a force that is applied during a period of time. जब हम किसी मूविंग ऑब्जेक्ट के ऊपर कुछ फोर्स अप्लाई करते हैं, तो इट विल apparently change its movement, it will change its velocity. So the momentum of the object will also be changed. So it is presented by a variable j, and in equation form it can be written as force impulse is equal to force times 4 multiplied by time. J is equal to F into T. Its unit is Newton seconds. And what is the impact? Impact is the time duration in which a change in momentum is occurring. कितने टाइम में जो change in momentum आ रहा है, वो कितने टाइम में आ रहा है? And its unit is actually seconds. Impact की unit जो है वो second है, and impact is actually the time. Means एक object जो है वो 20 किलोमीटर पर आवर की स्पीड पे मूव कर रहा है, and it comes to rest within 5 seconds. Then its momentum has been changed within 5 seconds, so the impact will be actually 5 seconds. Then impulse momentum theorem is there. Impulse is equal to a change in momentum actually. J is equals to delta P, or इनकी वैल्यूज अगर आप सब्स्टिट्यूट करते हैं तो जे एफ टी के इक्वल होता है, और चेंज इन मोमेंटम दिस इज डेल्टा एम वी के इक्वल होता है. सो एफ टी इज इक्वल टू डेल्टा एम वी. This equation can also be used to calculate the velocity, mass, time, or force applied on it for an object whose momentum is going to be changed. Then there is the law of conservation of momentum. Few important things regarding to momentum are there. Momentum is a vector quantity because it has a magnitude and a direction. And like vectors, the momentums can also be added with each other by with the help of parallelogram law or head to tail rule. So like forces, momentum vectors can also cancel out each other. And law of conservation of momentum, it is actually the statement is, in the absence of an external force, means if no force is external force is acting on an object, then the momentum of a system does not change, means it remains constant. So momentum of the first object plus momentum of the second object will be equals to the combined momentum of these two things when they will strike with each other. दो ऑब्जेक्ट्स हैं, मूव कर रहे हैं, एक तेज है एक स्लो है, ये दोनों अगर आपस में टकरा जाते हैं तो टकराने से पहले इनका जो मोमेंटम था वो टकराने के बाद भी उतना ही रहेगा, उन दोनों का कंबाइंड मोमेंटम टकराने के बाद और टकराने से पहले दोनों इक्वल होंगे. दिस इज कॉल्ड लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम. In equation form, it can be written as m1v1 plus m2v2 is equals to m1 plus m2 into vf, final velocity of both of these two. If the two objects strike with each other and then they start to move with the same velocity, then we can use even this equation to find out any missing thing from it, initial velocity of any of the two objects or the final velocity of the combined two objects. Or if they are going to move, not stick with each other, but start to move with different speeds after striking, then even we can use this equation. There is a problem relating to this law of conservation of momentum. Bullet with a mass of 0.020 kilogram collides inelastically with a wooden block of mass 2.5 kilogram, which is initially at rest. So after the collision, the bullet plus block, means both of them have stuck with each other, has a speed of 1.2 meters per second. Both have the same speed. So what was the initial speed of the bullet? Applying the law of conservation of momentum, ये भी आप use कर सकते हैं. पहली equation जो थी वो भी आप इसमें use कर सकते हैं. Then substituting the values, we can find out the initial velocity of the bullet with the help of this law of conservation of momentum. That's all, student, for today. Inshallah, on the next lecture, we will move towards our next topic. Up till then, thanks a lot. Take care of yourself and be conscious to your studies as well. Thank you and Allah Hafiz.